Developer Student Club.
Hello, everyone. Thank you so much for joining us for the JavaScript Data Structures event. We are excited to have you all here. Thank you for joining us. Today we have a guest speaker, Deepa, to give you an overview of the data structures and help you learn them. So hello, Deepa. Thank you for joining us. Yeah, I will pass it to you. So.
Yeah, thank you so much, Alexander, for having me. Thank you, Madhusha. Welcome. Good morning, good afternoon, and good evening from whichever part of the world you are from. Today we will see what are the JavaScript data structures. And who am I? My name is Deepa. I'm a software developer. I'm also involved with the community. I'm one of the organizers at Google Developer Group. I'm an ambassador at Women Tech Makers and a member of Women Who Code. And I also write blogs and Medium. These are the ways that you can follow me. And every slide would have my Twitter handle on the right top. And I would also post my LinkedIn at the end of this talk too. So today, the agenda is going to be, we will talk about Big O. We're not going to go deep dive into too much because Alexander has already gone through that. I'm not going to go through a lot in details, but we'll just do a refresher one, and we'll see what are the inbuilt JavaScript data structures such as arrays, objects, maps, and sets. We'll see how to implement a linked list, and finally we'll wrap it up with a Q&A. So my assumptions here is you have some understanding of data types in JavaScript. You should know a little bit of ES6 features. You should know what are classes, just to refresh your memory. Classes are templates for creating objects. Constructor is a special method of a class for creating and initializing object instance of that class. And you should know what does new operator do, what is a this keyword, and some ES6 for loops such as for off and for in, etc. And if you're familiar with code, any IDE or Chrome snippets, that will be helpful as well. So what is Big O? Big O is nothing but a notation that measures your execution based on the input size. It always measures the worst case. Complexities of a data structure can be measured either by omega, theta, or omicron. Don't think about the virus here, okay? So these are the ways that you could measure Big O. And in this talk, we'll be talking more on the time complexities. And just to let you know that any data structure can be evaluated and graphically represented like this. And the ideal ones are the ones which are closer to the x-axis. The farther away from the x-axis, you should avoid such data structures. It could be, the ideal one is Big O of 1, log n, linear one, and then please avoid O(n) square. There's a whole bunch of videos that Alexander has thoroughly explained. Here's a video that you can find out as well. I'm not going to press into this. Sorry about that. Okay, so what is a data structure anyway, right? So it is a collection of collection with a where you can define a way to access and store data. In simpler terms, you can manage and organize data. So different tasks and application requires different data structure. So now, what are the types of data structures? It could be linear or non-linear. So I'll be talking about arrays and linked lists today, but the rest was already covered by Alexander, and you can find out the link on the chat. So now today we'll talk about inbuilt data structures in JavaScript. So to begin with, let's see what is an array. Array, it's the most used data structure. It's a collection of items where you can identify them using an index, right? Arrays allows mixed types, and you can use arrays inside of an array too. So they are ordered list of data where duplicates are allowed, and it is contiguous in memory. So and it also starts from the index 0. When I say contiguous, it is all continuous in memory. So understand this with arrays. And now, what are the characteristics? Arrays keep their insertion order, meaning, for example, here the array that is pointing to the index 3, 21 is pointing to index 3, and it'll always be in the index 3. So arrays are iterable. You can use for/of loop to iterate arrays, and they are dynamic in size. That means that they are resizable. Duplicates are allowed in arrays. And like I said, you can also use mixed types. So there are some built-in methods with arrays. And some of the operations you can perform with an array is to add an item. You can use unshift. To add an item at the end, you can use push method. There is also something that you could do when you want to remove an item. You are from the first first item on the list. Then you could use shift. So I know that these terms are confusing, like shift and unshift. Remember that shift is you're shifting from one place to another one. So basically, you're removing yourself from one place to another one. So think of shift as like removing. And then I would also remember unshift as adding an item and then unshift. Both of them starts with a vowel. So A and U, think about it, remember this way, so that when you can add items, you use unshift. And there's also, for finding an element in an array is time consuming. You can use a find.index method. I'll show you in the code in a moment. And also we can remove an array or add from the middle using splice. So Alexander, can you just post the code snippet to folks? So here is, can you guys see my code snippet or no? Sorry about that. Can you guys see my code snippet?
No, sir, you cannot see it.
How about now?
No, it's your blank screen. Yeah.
Yeah, I think, let me drag it. Let me drag and drop.
Sure, no
Can you
worries.
see it now?
Yeah, now we can see your browser.
Okay.
Yeah.
Sounds good.
Yeah, the links are in the chat. So these are just like sandbox. You can
you can fork it.
Yeah, afterwards. Follow along. Yeah.
And here I have all the examples here for. I can also change this thing here. Okay, sorry about that. Okay. Yeah. So let's get started with this. For example, if there's a console at the end, so please pull over and see this. I have an array with a few items here, and I'm trying to console log and see the list of the number of items inside the array. If you see, there are 5 items starting with index 0, right? It's showing it as bread, milk, etc. So to find the length of the array, you could use array name shopping.length, and to find an element at index 2, you could also use the index number here. So if you do that, it's going to show cheese here. And then if you want to iterate over an array, you would use for/of loop. And this is a new syntax for in ES6. There are 3 types of loops that are available: for/of, for/in, and for each. You can use for/of for iterating over an array. and you see it's all listed here. And then to add an array from, you can also use array name dot push. So note that when I do that, it is getting added. Cheese is getting added at the top of the list, and you see there are 2 items with the same name, cheese. So duplicates are allowed in array. So to add an item at the start, you would use unshift. Remember, I said that adding at the beginning, add and unshift starts with the vowel. So remember it that way. So when I do that, it's going to show up here. Let me see if I can do this on a different window. So with that, so I think if you go ahead and do this, so, and I have to do console log. Sorry about that. So when I do this, if you see, bagel is listed here, right? So that's one thing that I wanted to show. Bagel is on the top of the list, and we can also find an element using find index method here. Arrays have a lot of inbuilt methods. So if you go to MDN, you would find a lot more than what I'm using here, but these are the common ones that you would be using to find an index of an array. For example, I'm trying to find the index of noodles here, so which would be, let's see, what does it do? So if I do this and console log it, so it's showing me, oh, the index of noodles is at 5. So for removing an array from the middle, you can use splice. Note that if you start off with, if you want to remove an element here, so the code here is all available to you, so you can go around and play with this and see how exactly splice work. For example, here I'm using splice of 3 and 1, so it is going to remove the cheese that we added here at the middle. So that's one thing that I wanted to show. And to remove an array from the beginning, you would also use shift. So if I do that, if you see, the bagel one is no more there. And if you want to pop an element at the end, you can also use shopping in a pop method here. So these are the various methods that are available. And I also wanted to show you that array can contain mixed types. Here I have numbers, and inside an array I have another array. And for you to access the arrays, you can use the index number. So here, if I do this, it's going to show, okay, this is the 0, 1, and then this is the first element in the index 2, but then this is 0, 1, and 2 again. So Google will be displayed here. Hope that makes sense. So now moving on to how does it connect with BigO, right? So when you add or remove an element from the beginning or middle, it's going to be in linear time. But when you add or remove at the end, it's going to be at constant time. So arrays are efficient when you are trying to do any operations with O of 1. So that it also depends on the input size. So now let's move on to sets. Sets are a list of data with no indices. You don't have any index like arrays. And note that here we are using the new keyword, new operator, to create a set, which is an inbuilt object type that is a constructor function. So sets are also iterable using for of. The keys here are unique, but the values are not. When you have multiple keys and you're trying to, when you have it, it overwrites the value. We'll see an example very quickly. And these are also resizable in size. And yeah, then let's move on to the characteristics of sets. It's a unique set of collection. The insertion order here is not preserved, like how I showed you in an array. For example, the third index was always pointing to the value 21. Here, it's not the case. The insertion order is not kept. However, deletion and finding something in a set is super fast. So there are some built-in set methods that you could use to add an element. This is very easy to remember. Add, delete, and the has method is available for you to find something inside of a set data structure. The new operator here creates an instance of a set. So let me try to go to the code here. And Alexander, please let me know if you can see my screen.
Yes, everything's great. Cool.
So if you want to access this, you have to use one of this script tag. Make sure that you're using the right one. I also have examples for object and map here, but we'll see it in a bit. Set. So here we are adding a value to the set, right? We are creating a set with a name, with a string called Google, and then we are adding a few more here to the set, and we can iterate over. And if you see it in the console here, so it is iterating through every single item here. And then it also, when I say if I want to access an element inside of a set, I'm saying .has method, which returns true. And if you go ahead and see what are the things that are available? If I want to delete the string called group, and then try to get what are the things that are inside a set, here it is showing up as Google and developer only, not the group is shown here. So order does not matter here. It's very easy to look up and delete stuff from a set's data structure.
Yeah, sorry, Deepa, I will pause you for a second. So there was a question. Could you please mention the time complexity for each method, like maybe add and remove?
Yeah, I'm coming. That's the next one.
Okay, cool. Thank you.
Yeah. So if you see, when I say add, delete, and search, which is add method, delete method, and .has method, it would be a time complexity of O of 1. Okay. And moving on to the next. So just to give you a comparison between arrays and sets do not contain duplicates. And it does not have to go, like, you don't have an index for sets, right? And also sets are keyed collection. Order matters in an array. Duplicates are allowed, but the most widely used data structure is arrays. But one drawback for arrays is it's hard for if you are trying to find an item or delete an item, you have to iterate over the whole entire collection of data. So that might take some time. So performance-wise, arrays, when you are trying to find something, it's going to be slow. So we saw what are arrays, we saw what are sets. Now let's move on to objects and maps. So these are reference type reference type data types too. So objects are key value pairs of unordered data. So retrieval of data is using keys, and it contains properties and functions. Functions are nothing but if you have a method if you have a function inside of an object, it's called methods. And here, how do we retrieve data from an object? You either use dot notation or a bracket notation. And like I said, it's unordered key value pair items. You can access using properties. And here you would use for in loop. And keys must be unique. Here in objects, multiple properties can have the same value. So values need not be unique here in this case. So here's an example that I have. So I have a object with a name called person, and then I have a property with name. Note that here I'm using an array, and there's also another property with age. It can have, like I said, it can have methods, and if you see, I'm using object literal. This is a ES6 syntax, so you should be familiar with object literal too. So the object which contains this method is it's being invoked by this keyword, and there's another method called greeting. And if you see in the output, I think you have the code. If you go ahead and try to see how it works, you can also change the value here for the array, and then try to manipulate and see that. And like I said, how do you access an array? How do you access an object? You can use the dot notation and the bracket notation here. But dot notation is more widely used over bracket notation, because sometimes you tend to make typos when you try to use those codes. And you can also access methods of an object using the method name here. So yeah, here with objects, searching for a value, then we need to go through the entire list, entire item. So it would be O of n, but then adding or deleting or accessing, like how I said in the previous slide, it's going to take linear time. Now, moving on to sets. These are also ordered key value pairs of data. You can iterate over an array of maps using for of. Keys are unique, like before, and then you can have multiple keys. When you have multiple keys, it overrides them. So yeah, it is mainly used for pure storage. For example, if you want to store something, you don't want to have any functionality, then this would be a better choice. So here is an example for maps. I have a map I've created. I think I've made a mistake here. Sorry about that, guys. It should be map here. It should have, it has latitude and with a value here. And then you can also create a map with objects. And then you can also you can also have object inside of a map too. So like I said, you can have, you can iterate through maps. And then if you write, if you try to have the same value, it'll overwrite them. So what is search for value? If you're trying to search for something, we need to go through every single item here, and that's why it would be linear time. And then the has, get, or set method, which you would see in the code snippet, would have constant time. So when would you use maps? You would use maps when you want to preserve the order, and it's only for accessing. When you don't want to store when you don't want any functionality, then you could use maps. They are very fast in certain cases. However, objects are very commonly used. It can contain data types such as integer, strings, or symbol. The order is not preserved here, and it's meant for functionality. So we talked about, so far we talked about built-in data structure. Now we'll move on to another famous data structure called linked list. So we can customize our own data structure, and linked list is one of them. You can customize it. It can be anywhere in store. It can be stored in memory, sequentially. It is not like arrays where you have it's contiguous in memory. It's not like that. So linked lists also have a head, tail, and a null pointer, like how you see it here. Head is always the beginning of the list, and tail would be pointing to the last item, which is pointing to null. So just to give you a visual, on the left, you see arrays which are contiguous in memory, but then in linked lists, it can be anywhere, but they are stored sequentially. And just to, if you want to visualize as how linked lists would look like in code, this is how it look like. So if you see here, head is pointing to 8, which is why the value of 8 is here. And then going so on and so forth. Tail is pointing to the value 10, which is here, right? And then we just point, the next item on here is null, which is why I've represented this as null here. So now what are the common operations that you can perform with the linked list? Either you can insert something, an item at the beginning or at end, deleting at the beginning or end. And then you can also insert and delete something from the middle. And you can look for an item with using the index. And you can also insert something based on the value at an index. And you can also remove an item from item using an index. And you could also reverse a linked list. For the sake of this talk, I would be implementing the following. We'll start creating a node. We'll create a linked list with a single item. We'll add something at the beginning and at the end. We'll remove as well. And I have some resources for how to find by value and index, and how to reverse linked lists, and I can point out to you towards the end. Or you could also try it on your own with whatever knowledge that you would be gaining in a few minutes. So here, what is a node? A node is something that contains value and a pointer. If you see here, this is a node which has a value of 8, and then it's pointing to null, right? So you create a node using class constructor here. And the new operator here creates a new object. And under the hood, everything in JavaScript is object, guys. If you try to look into the console, if you go to Chrome snippets, and you try to go through this and try to console log anything, you would always, if you look closely, everything would be an object there. So here I'm creating a new node with a value of 8. Now, this is, so here, I just wanted to show this. This dot value is the current value here. And this dot next is pointing to null. That's how you create the new node here. And here is a linked list with a single value, which the head and tail is pointing towards the value itself. So we are going to be creating, again, here in the previous slide, we saw how to create a node using class constructor. Here we are going to create a class for a linked list, and the constructor like the node class, which takes a value. For example, here we created the node, and then here we are creating a constructor for linked list. And note that we are also using the new operator here, which calls a node constructor. And then down here, we are using the new operator again to create a linked list with a new keyword. And here also the value is 8. And note that the head and tail are pointing to new node, which is nothing but 8 here. And the length is also 1. So now let's see how to add an item. Alexander, is there any questions so far? Because this is going to be, the next few slides are going to be a little bit more intense. If not, I can move along. So
sorry, it was just a small technical delay. Yeah, there is a question actually. One question. So what's the benefit of a linked list over a set, dictionary, or other data structure like an array?
Okay, I am here to talk only about the JavaScript. I'm if you want to compare between two different languages, every language has its own pros and cons. I have not used dictionaries, so I would stick on with JavaScript linked list here.
Yeah, but like maybe let's rephrase the question. What's the benefit of a linked list over an array?
I'm coming to that. Just give
Okay.
me a minute. So let's see how we can add an item at the end. Just focus on this code. Just focus on the animation first. Then we can start looking into the code. So here, to add an item, we check two things. One, to see if the tail and head are pointing to null, right? And then if it is not, then it'll create a new node, right? Otherwise, if there is already items on the linked list, what it does. So here, if you see, it points to this dot tail dot next, which is here, right? Number 6, and which is the new node, right? And this dot tail is now pointing to new node. And what happens is when you do that, it gets incremented and you return the entire list. I hope it made sense. So if you have not watched the animation once again in the recorded ones, and so that you would get more idea about this. Adding an item is like this in an array. So you have to check for two conditions, whether there's any item already on the list or not. Otherwise, it creates a new node. If not, then it'll make sure that the tail is pointing to the new node. And then you have to increment the list. So now, adding an item to the start, right? This is very similar to adding to the end. Here also you check if there are no items on the list, then you point to new node. Otherwise, if there are two or more, like here, you would say, okay, new node dot next is pointing to the head, the current head. And then when you do that, this dot head becomes the new node, and then you increment the length by 1. So then when you say return this, you're returning the entire linked list. Okay. Now the tricky part with linked list is deleting an item at the end. Okay. Here we have, when we remove an item at the end, the tail cannot go back here. So for example, this cannot, I'm trying to remove number 6 from here, and the tail cannot go back like this. So for you to do that, you have to iterate over all the items on the list, and it takes a constant time here for that. So if you see, here we are going to be checking for 3 conditions. 1, if there is no items at all. If the list is empty, then return undefined. 2, if there are items, 2 or more items, then we create a couple of variables, which is current, which is creating a variable called current, and previous, which will be pointing to head. While this is there, we have to iterate over the array, whole list of items, linked list. So how long we do this? Until we have current.next. So which is current.next, which is also current is pointing to prev, and current is also until it goes through current.next has something, right? And when you have it, this when you reach at a point, previous would be pointing to tail, right? And then when you have tail.next, then it points to null, then you decrement this. So you remove the item, and you also need to check for the last condition where there's only one item in the list. So there's nothing to remove per se, right? So when there's one item in the list, go ahead and do this. So and then return the current item, right? So this is how deleting at the end, it is tricky, but it's if you pay close attention to what are the things what is popping in, what is popping out, then you would be able to understand much better. So deleting an item at the start is also very similar. However, here you have only one variable. So head will be, there's a temp variable which is pointing to the current head, and then this dot head is equal to this dot head dot next. When we do that, sorry about that. Okay, just give me a minute, Alexander. This is taking some time. Okay, sorry about that. Let's go through this again. So here we have just give me a minute. Okay, sorry about that. So deleting an item at the end, again, at the start, here we are creating a temp variable. This dot head is pointing to the temp variable, and then we are decrementing it when we have this dot head is pointing to next item, right? And then we decrement it, and we also check if there is any, if the list is empty or not. So similar concept, similar operation, and then we return temp here. So now, so searching for a value, then we need to go through the entire list again. So you will have a linear time. Here it becomes very linked list has benefits if you are trying to add or remove at the beginning, right? So let's see when would you use every data structure has its own benefits. So when would you use a linked list over an array, right? All these operations such as pushing an item in an array or removing it or searching by index are all big O of 1. And for linked list, it's only adding at the end and start, adding at the end and start, and removing at the beginning would be beneficial. If I don't know what would be your use case, it depends on what kind of operations that you want to perform. And based on that, each of these data structure has its own benefits. However, having said this, it also depends on the input size. So with that said, understand each data structure has its own specific use case. It's based on your needs. That's what I want to end up with this talk. We did see, I just want to summarize, we did see what was big O, and then what are the built-in data structures in JavaScript. And we also saw the implementation of linked list. So to further go ahead and improve or increase your knowledge in this, try to take this and probably work on what is a doubly linked list, right? Singly linked list, it has only one pointer, but then doubly linked list, what is it? How can you implement it? You can go with that to the next step. And Alex, we have a quiz time now. So if you guys can, okay. So what you can do is, if you are confused with, I wrote a series of JavaScript data structures articles. You can go ahead and start with, there's something that I wrote with what is a big O notation. If you want to read more through it, and if you're confused whether it is big O always measures worst case, why I have written those things in the article, please go ahead and read through this. And for reversing a linked list and finding it by index and value, I have the code as well as the gist for it in my articles. So please go ahead and check it. And these are my references. And these are the ways you could connect with me. Thank you, Alexander, for having me. And thank you so much, Madhusha, for this opportunity.